Before life appeared on Earth, before oceans formed, before our planet cooled enough to hold an atmosphere, another world was coming to life beside us. Venus, a planet so similar to Earth in size, mass, and composition that scientists once believed it might hide lush jungles beneath its clouds. But today, we know the truth. Beneath those clouds lies a landscape more extreme than anything science fiction could imagine. Picture standing on the surface. The temperature is over 470 degrees Celsius, hot enough to melt lead. The pressure is 90 times greater than Earth's, the same as being almost a kilometer underwater. The sky glows orange. Lightning crackles inside swirling acid clouds that stretch endlessly across the horizon. Winds rage through the upper atmosphere at hurricane speeds, while the surface below remains eerily still, locked in eternal silence. Yet the greatest mystery is not what Venus is now, but what it used to be. Billions of years ago, the young sun was dimmer, and Venus might have been a mild blue world. Some studies suggest oceans of water could have covered its surface, reflecting a young star that shone only 70% as bright as today. Imagine waves crashing against volcanic shores, clouds carrying water vapor instead of sulfuric acid, and a climate that might have been surprisingly stable. If Venus truly had oceans, then for a time, it might have been habitable. But something went terribly wrong. A series of small changes, increasing sunlight, rising temperatures, bursts of volcanic activity, triggered a runaway greenhouse effect unlike anything in the solar system. The oceans evaporated into the atmosphere. Water molecules broke apart under solar radiation. Hydrogen escaped into space forever. With the loss of water, the planet crossed a point of no return. From that moment, Venus became a furnace. The atmosphere thickened with carbon dioxide. Sulfur dioxide from colossal volcanic eruptions created a toxic veil around the planet. And as the heat intensified, Venus was reshaped, its surface melted, cracked, and renewed itself in a global volcanic catastrophe. Today, Venus stands as a warning. Two twin planets, two opposite destinies. One became the cradle of life. The other turned into a world where life as we know it cannot exist. In this video, we'll journey back in time to explore the rise and fall of Earth's mysterious sister and uncover how a world that may once have been calm and blue transformed into the bright, burning star in our morning and evening sky. Quest for knowledge. To understand Venus, we must travel back 4.6 billion years to a time when the solar system was nothing more than a swirling storm of dust, gas, and newborn chaos. There was no sun as we know it, only a massive collapsing cloud, a nebula twisting under its own gravity. As the cloud tightened, temperatures soared, forming a glowing protostar at its center. Around it, a disk of hot debris spun like a cosmic whirlpool. Inside this disk, tiny grains of rock began to collide, sticking together, growing larger every million years. These were the first building blocks of the planets. Within this violent birthplace, two worlds began forming side by side, the early Earth and the early Venus. At first, they were almost identical, molten spheres of rock, glowing with heat, bombarded by asteroids, constantly reshaped by collisions. Each impact melted parts of their surfaces, releasing steam and gases that would one day become their atmospheres. But Venus had one significant difference. It formed just a little closer to the newborn sun, close enough that a single degree of temperature, a single additional watt of sunlight would change everything. As the planets grew, the largest collisions shaped their destinies. One enormous impact may have slowed Venus's rotation to the strange backward spin we see today. A day on Venus became longer than an entire Venusian year. Another collision may have added more mass, giving Venus its Earth-like size and density. After millions of years of chaos, Venus finally stabilized. Its molten oceans of lava began to cool. A crust formed. Volcanic activity raged across the surface, releasing thick clouds of carbon dioxide and steam. And as the heat radiated into space, the first atmosphere of Venus began to take shape. At this moment in time, Venus and Earth were almost the same age, the same material, the same potential. Two sister planets emerging from the same cosmic furnace. But this near twinship would not last, because even in these early stages, the seeds of Venus's future catastrophe were already being planted, hidden in its position, its rotation, and the delicate balance between heat and light. The story of how Venus transformed from a young, fiery world into a possible ocean planet and later into a suffocating inferno begins here at its very birth. From that moment, Venus became a furnace. The atmosphere thickened with carbon dioxide. Sulfur dioxide from colossal volcanic eruptions created a toxic veil around the planet. And as the heat intensified, Venus was reshaped. Its surface melted, cracked, and renewed itself in a global volcanic catastrophe. Today, Venus stands as a warning. Two twin planets, two opposite destinies. One became the cradle of life. The other turned into a world where life as we know it cannot exist. In this video, we'll journey back in time to explore the rise and fall of Earth's mysterious sister and uncover how a world that may have once been calm and blue transformed into the bright, burning star in our morning and evening sky.
After the chaos of its formation settled, Venus entered a period that remains one of the greatest mysteries in planetary science, a period when the young planet might have been far more Earth-like than anyone once imagined. 4 billion years ago, the sun was dimmer, shining at only about 70% of its current brightness. This gave Venus a chance, a narrow window where temperatures may have been low enough for liquid water to exist. Imagine early Venus beneath a softer, gentler sun. Volcanic plains cooling under thick clouds of steam. Rainfall condensing for the first time in the planet's history. Vast oceans collecting in ancient basins spreading across the surface like the young seas of early Earth. If these oceans truly existed, they could have lasted for hundreds of millions of years, long enough for tides, currents, and a stable climate to shape the planet. Some climate models even show a warm and humid Venus with shallow seas and long coastlines, a world with blue horizons, a world where water cycled between ocean, cloud, and rainfall, just as it does on Earth today. But there was a fragile balance at play. Venus received more sunlight than Earth, not enough to immediately destroy the oceans, but enough to push the climate toward instability. Its slow rotation meant that one side of the planet spent months bathed in sunlight while the other lay in darkness, creating extreme patterns of heating and cooling. Thick clouds may have blanketed the sunlit side, reflecting light back into space and cooling the atmosphere. For a time, this balance held. For a time, Venus may have been a calm, watery world, an unlikely paradise. If life ever had a chance to emerge on Venus, this would have been the moment. But the early calm would not last. Deep inside the planet, enormous volcanic forces were building, and far above, the sun was slowly growing brighter. The delicate equilibrium that kept Venus cool was beginning to strain and soon would break. The story of the planet's oceans and their ultimate disappearance marks the turning point in Venus's history, a turning point that would lead to the most dramatic transformation any planet in our solar system has ever undergone.
The era of calm on early Venus was fragile, a brief moment of stability suspended between two extremes. But deep inside the planet and high above it, forces were gathering that would soon erase every trace of that peaceful world. The sun, once dim and gentle, had begun to grow brighter. Even a small increase in solar radiation meant that more water began to evaporate from the Venusian oceans. Water vapor, one of the strongest greenhouse gases, trapped heat in the atmosphere, raising the temperature even further. More heat created more evaporation. More evaporation created more heat. And with that, a dangerous cycle began, a runaway greenhouse effect. At first, the changes were subtle. Days grew hotter. Nights no longer cooled as much. Clouds thickened, reflecting sunlight but also locking heat below them like an enormous thermal blanket. Then came the tipping point, the moment from which there was no return. As temperatures continued to rise, the oceans of Venus began to boil. Gigantic clouds of steam filled the sky, creating an atmosphere thicker and heavier than ever before. The planet's surface turned into a vast pressure cooker. Far above, ultraviolet light from the sun attacked the rising vapors. Water molecules were broken apart, hydrogen escaping into space, oxygen reacting with the hot crust and volcanic gases. Slowly, inevitably, the planet was losing all of its water forever. Without oceans, the climate collapsed. Carbon dioxide from volcanic eruptions flooded the atmosphere. Sulfur dioxide added layers of toxic clouds, spreading high into the sky and creating a reflective, suffocating veil. With no water left to absorb carbon dioxide or cool the surface, the greenhouse effect intensified beyond anything imaginable. The pressure soared, the temperature raced upward to nearly 500 degrees Celsius. Metal would melt, rocks would glow, the air became dense enough to crush landers sent from Earth. Venus had crossed the threshold, transformed from a possible ocean world into the hottest planet in the solar system. The story of the runaway greenhouse isn't just the story of Venus. It's a cosmic warning, a demonstration of how a world so similar to Earth can take a drastically different path, shaped by delicate balances of sunlight, chemistry, and time. But the transformation wasn't finished yet. Beneath the surface, something even more catastrophic was preparing to erupt. A global volcanic event that would reshape the entire planet.
As Venus's climate spun out of control, a cataclysm of fire and stone awaited beneath the surface. The runaway greenhouse was not the planet's final act. It was only the overture. Deep in the mantle, pressure and heat built to unimaginable levels. Magma chambers swelled. Volcanic systems became ferocious engines, ready to erupt with a fury the likes of which few planets can match. Massive volcanoes unleashed torrents of lava across vast plains. The crust cracked and reformed, folding and stretching under internal stresses. Old terrain collapsed. New plateaus rose from molten rock. The world became a dynamic, roiling inferno. With every eruption, volcanic gases poured into the already suffocating atmosphere. Carbon dioxide, sulfur dioxide, and other volatile compounds. These gases thickened the cloud cover. They reinforced the greenhouse effect, trapping more heat and contributing to the toxic sulfur-rich haze that cloaks Venus today. The toxic cloud layer also helped reflect sunlight, but that reflection came at a deadly cost. Acidic droplets condensed, forming dense sulfuric acid clouds. Lightning cracked through them, and strong winds carried these toxic droplets across the planet. Under this relentless volcanic onslaught, the surface of Venus remained geologically young. Radiometric dating of Venus's surface suggests that much of it is only hundreds of millions of years old, geologically recent. The constant resurfacing erased craters. Old landscapes were buried under lava flows. Meanwhile, the planet's geology and the outgassing of volcanoes kept feeding the hellish atmosphere. The sulfuric acid in the clouds, combined with high heat and pressure, created a vicious feedback loop. Volcanic eruptions added more gas. The atmosphere grew denser. The greenhouse effect intensified. The planet heated up, and more volcanic activity was triggered. This volcanic apocalypse did more than just reshape the surface. It transformed Venus's very identity. No water remained. No stabilizing ocean cooled the crust. Every volcanic eruption reinforced the runaway climate, driving Venus deeper into its infernal destiny. Today, what we see from space, those thick cloud tops, the blistering surface, the stagnant pressure-choked heaven, are relics of that global volcanic rebirth. Venus is not just a hot planet. It is a living testament to how internal planetary forces can reshape a world in fire.
After billions of years of transformation, Venus now stands as one of the most extreme environments in the solar system, a planet where the rules of nature bend, twist, and push physics to its limits. A place that seems almost impossible, yet it exists right beside us. The surface of Venus is a landscape of crushing pressure, over 90 times stronger than on Earth. Standing there would feel like being deep beneath the ocean. The heat, reaching nearly 475 degrees Celsius or 900 degrees Fahrenheit, is hotter than the surface of Mercury, even though Venus is farther from the Sun. The skies are thick with carbon dioxide. A permanent shroud of sulfuric acid clouds reflects sunlight so strongly that Venus shines as one of the brightest objects in the night sky. But beneath those clouds is a world where light never reaches the ground. The landscape is dim, orange, distorted by atmospheric density. Lava plains stretch endlessly. Volcanoes, some dormant, some possibly still active, rise from the scorched crust. Winds in the upper atmosphere race faster than hurricanes on Earth, circling the entire planet in just a few days. Yet, near the surface, the air is so dense that even strong winds become slow, heavy movements. There is no water, no oceans, no rainfall that reaches the ground. Only a deadly cycle of evaporation, acid condensation, and high-pressure storms. This is Venus today, a world remade by greenhouse heat, sculpted by volcanic fury, and sealed beneath suffocating clouds, a place that might have once been alive, but is now locked forever in a silent, burning stillness. A warning from across the solar system. Venus is more than a distant, hostile world. It is a mirror that reflects a possible future for Earth. Both planets were born from the same cloud of cosmic dust. Both may have once had oceans and warm sunlight and stable climates. Yet their paths diverged dramatically. Something on Venus triggered unstoppable heating, a feedback loop that spiraled out of control, a chain reaction that destroyed oceans, thickened the atmosphere, and transformed the planet into a furnace. Understanding Venus is not just science, it is survival. By studying its past, we learn how fragile planetary climates can be. We learn how quickly balance can break, and how a stable world can fall into irreversible change. Venus teaches us that a greenhouse effect can reshape an entire planet permanently. It shows that climate is not guaranteed. It must be protected, or it can be lost forever. As missions like Da Vinci, Veritas, and Envision prepare to explore Venus in the coming decades, scientists hope to solve the mystery of when and why Venus turned into a world of fire. And in answering that question, we may better understand how to protect the only habitable world we know, Earth.
Venus shows us the power of nature and the consequences of imbalance. It is a story of creation, destruction, and transformation, a cosmic warning shaped through fire. If you enjoyed this journey into the history of Venus and want more deep space stories, mysteries, and cinematic science, subscribe to the channel, like the video, share it with someone who loves space. Your support helps bring more cosmic stories to life. Thank you for watching.